Okay, we're back again. So this is my 2N222, and I'm going to put it there for now. It's not going to fit. Oh, come on. Probably should have done this before I restarted the video. You always got to put their legs just a little bit apart. Alright, so according to my little thing here, collector, base, emitter, going that way. And let's have a look at my little diagram. So, the first thing is the emitter is going straight to ground. So we're going to talk about why in all these things I put the emitter straight to ground at a later point. I don't want to use those. I don't want to use those wires. Sorry. They're just too ugly. They just really are. Alright. So I'm one of these. And that one, oops, I probably broke something. Nope. Alright. So it's going to keep flickering around because this isn't connected to anything. So I haven't actually done this properly because I haven't tied all my inputs to low or high. So remember, with CMOS things, always tie the inputs to something. Otherwise, it's just wasting power doing nothing, but I don't care at the moment. So we've got that part done. So the emitter is now connected to the thing, and this little thing is going to, I think I can plug this straight in right now without having to worry. But I need a pull-up resistor. So where was the one that I just had? So these are all the things. There's a big mess here. 2K is not high enough. We want a really high one. We don't want 1 million. I think that's too high. But I don't really know. It doesn't really matter that much, to tell you the truth. It does matter because you should always think about how much, what your I don't know how to say the word, but there's the 10K ones. Okay. Well, let's just do 10K. Everyone does 10K. Does that say 10K or not? Okay. So, if you look at this, 10K is going to be going. Have I got the? I always get worried that I've got everything wrong. So there's a 10K going from the positive rail into the collector. So you can't really see what's happening yet. But I'm going to need another buffer thing, aren't I? Okay, so that's going to there, and then so we've done the top part now. So this is going to the positive rail, which is what I've got here. So this is my 10K pull-up resistor. It's going into, I have to bring it up a bit closer so you can get a good kind of look. So you can kind of see what I've done. And also on the same thing, we've got the input going into there. So now all we need to do is we need to connect up. So I'm just going to use I'm going to use a 22. I want to make sure that we've got enough current going into the base of this such that this thing is fully on, basically. I want it to reach saturation because I want it to be really pulled down as much as possible. I don't think it really matters too much. When I tried this before, it wasn't too much of an issue. So now we just have to put the clock pulse into there. And we can probably just go straight off. We don't even have to use the buffered one. So we will just go off. Oh my goodness, this is hard to get the thing in. Alright, so this is the clock pulse coming here. And then we're going to attach that into this here. And voila, you've created yourself an inverter. So as you can see, the two LEDs are opposite each other. So when that one is, and hopefully it isn't actually affecting it, so it doesn't seem to be affecting the rate. So before I had all these problems because I was loading everything down, that the rate would change and it would all be a bit strange. But now that we're buffering everything, it's all quite nice and happy, even though we're actually going straight off. So there is going straight off. So you can see in the end we are going to be able to drop the 4050. But anyway, I hope you can kind of get what we're doing. So that's created a little mini inverter without using a 4049. And then we can take, so instead of sending this signal to the we can actually do this. We might as well finish up tonight by actually getting it to be fed into the chip. So I'm going to have to bring up my data sheet piece of paper first. So, because I forgot which pin is actually the latch clock. So here's the little picture again. So this is, it's pin 12. So looking in here, so it's going to be one of these ones that go from here. And I've got it, what's pin 12? So I'm going to look at my little, where's that little pencil? Alright, so just counting from here. So this is pin 9, so that's my Q dash. That's the serial clear, which is being pulled to high all the time, which is good. And then we've got serial clock, which also has a wire going over here for no reason at all. So that's the red wire, that's the serial clock. And the brown wire is the other clock. So I can actually, we can just continue. We're not going to buffer it. We're not going to buffer it. We are going to take this one and we're going to put this straight on. Can we do that? Should we be doing that? I don't really know. No, I don't have to do that. I want to leave that wire there. So that one's going there. But, and in fact, we don't have to. We can just fan it out a bit. So this thing here, I wonder if we can. Well, I'm going to stick it there. Actually, we don't have to do that at all. We can just take this wire and put that wire on the output of this. So let's try it now. So hopefully it kind of works. So wait for it, wait for it, wait for it. So, wait, I did it wrong again. Okay. And now. Oh, it doesn't work. Yeah, maybe I've got it wrong. Hey, it kind of worked that time. But, like, it kind of will work, but you have to hold it down the whole time, maybe. The problem is, as we went through before, I've got the clock the wrong way around. So, oh, I'm just going to spill water on my cell phone. If the clock looked like that, so if it was flashing like this in the first place, this would be quite cool. And we can always do that, of course, by exchanging this one for a 4049. So we'll do that actually. So this clock here is, so here's my 4049 that I actually had before and I pulled it out. Oh, where did I put it? I had the tool a second ago. Like, it's green. Where can it go? Where is it? I'm trying to find the little chip extractor tool, which I used only momentarily before I even did this video to pull that IC out. There's my house keys. Don't need those. I think they'd be around here. Well, I'm not going to do it then, because I'm not going to pull the chip out without using the proper tool for it. Well, that's disappointing. It's always the same, isn't it? Can't find the simplest things. It must be on the floor. It's not on the floor. Okay, well, I can't spend all day humming and hurrying, so we'll give it a go with this thing here, which the worst pliers ever, so we won't use the worst pliers ever. We'll use the better pliers. These are not the right kind of thing, but I mean, what are you going to do? Not everybody has the right tool. So I'm going to take it out while it's still working and see what happens. Alright, please come out. Oop. This is not the best tool to use. Hold on. That's not the screwdriver I want. Okay. I feel it's getting into far too boring territory. But we'll just lift it up there. It's actually not that hard to lift it up this way. Alright, so now it's all stopped working. So we're going to take my 4050 out and we're going to stick the 4049 in. So remember, the pin out for that is exactly the same as for the 404. So you can now see what I mean. So now we've got a short pulse here and we've got a long pulse here because we've inverted it twice. So this is actually the original pulse that's coming out because it's being inverted twice. Once by the 4049 and then once by a Mickey Mouse circuit. And now, so hopefully it will work a little bit better. So, oops. Oh, it works pretty well then. It works sweet. and then you've got 3. So now it's nice because you've got a nice short little pulse, and so you've got that it's latching, it's doing the serial shift, and then it's latching real fast straight afterwards in that little flash time. But, okay, the trick is we can do a little bit better than this and a little bit simpler than this. So that's what the next video is going to be about. It's the next way of doing this, of delaying the pulse. So I hope you enjoyed what you just saw. Sorry, it's very disorganized. That's why it's taken me so long to actually get around to doing this, because I had to plan the whole thing and it didn't go well. So thanks, I'm not going to tidy up now. Thanks for watching. Say goodbye to all these ICs. But the last part in this video, we're going to introduce a new IC in order to test whether I've got this correct without having to press the buttons, because you can't really trust that I'm saying this is working or not. Because if you're watching this, you're like, I don't understand the problem, I don't understand how you know that it's working, and I don't understand how you don't know that it's not working, and blah blah blah. So we will find a more scientific way of determining whether or not we've got this correct. So thanks for watching, and when you have limited instrumentation. So if you have a really cool oscilloscope, then you will be able to do that quite easily. But if you don't have a very cool oscilloscope and you have a very basic one like I do, then we have to work out something a bit different to see that we've got it to work. So thanks for watching, like, share and subscribe.